all have listened about water treatment, greenhouse gases, in farms. Specifically, we know the bad odor of big farms, or not very comfortable. But how does that really work? Or how does that affect our life? Today, Dr. Chou and we are gonna make the science behind that edible for everybody. Así que toma pulque y come nopal, que el Pulche Podcast va a comenzar. It's my pleasure to welcome Dr. Chou. Dr. Chou, good afternoon. How are you?
Okay. Thank you
Fine.
for your introduction.
No. Just a very brief one. Doctor, how would you describe yourself?
Okay. I'm an associate professor in Department of Biomechatronic Engineering.
Yeah.
Okay. And having working in the wastewater treatment for more than 30 years.
Yeah, I've seen some parts of your story that you are part of the American Society of Agricultural and Biological Engineers, World Agricultural Society. Can you tell us more about those?
Okay. Because I having studied in America, I mean United States of America for 7 years. So I think because I have been trained over there, so we always participate in that kind of academic society, and also we have the similar society in Taiwan, okay.
And through these societies, what do you research about? We just introduced that it is about the automatic controlling farms. That would be type of smart farms. Can you tell us about it?
Okay, actually, during my studying period, my training was waste and wastewater treatment, but it's majorly is a biological treatment. I think that's probably in master's degree, but for PhD degree, then my dissertation is about the computer control of the anaerobic process.
Anaerobic
Okay.
process.
So-
Anaerobic process is the process happening without air, without the necessity of
without
air.
oxygen.
Oxygen.
Oxygen is toxic to
Okay,
those
sorry.
bacteria. Yeah. Okay, so with the first background is the waste and wastewater treatment, and the second background is automatic control, is computer control. So I think so when I back to Taiwan and we have that kind of requirement, and then I can integrate these two together. So I'm doing automatic control for the wastewater treatment system.
Okay, what are the parts of a waste treatment system, and why should people apply that in their farms?
Okay, actually in Taiwan, we already have the wastewater treatment system. We already have, but the thing is, because probably they will have the problem in to meet the government regulation. I'm talking about the regulation about the effluent standard.
What type of regulations are there?
The effluent, okay, that means the discharge, the water quality of the discharge effluent. Okay, we have the limitation for BOD, for COD, and the suspended solid, but I don't know, probably this is some terminology for common people.
Can you tell us a little bit more about that terminology?
Okay, when we say something like related to oxygen demand, that is more related to organic matters.
Okay.
And suspended solid, okay, it's an index. It will affect the turbidity or the transparency of the water. Okay, and that is a basic effluent standard in Taiwan. Yeah.
Okay.
Okay.
How about the other one? COD?
Yeah. Okay. Yeah. Both COD and BOD, they are all oxygen demand, but one is a chemical oxygen demand. Another one is a biochemical oxygen demand.
Okay.
Okay. And biochemical oxygen demand, that is an index, and when you analyze that, you need simulate the real bacteria system.
You need the bacteria in order
Okay.
to calculate this index called BOD.
Yeah, for the chemical oxygen demand, that just use a strong oxidant
Yeah.
to completely oxidize those organic matter. So they have some difference. The COD always larger or equal to BOD.
Yeah.
Okay.
This COD is larger. COD stands for chemical oxygen demand.
Yes.
So this one is larger because of we only focus on the chemical reactions, and for the BOD we have bacterias that help us with that
Yeah.
process. Am I right?
Probably. Okay.
Probably.
I want to explain more about that.
Okay, please.
Because in Taiwan, we already have the 3-stage treatment system.
First stage
Three-
is
Okay. The first stage is solid liquid separation.
okay.
And then, the solid part probably will go to for composting. But for liquid part, okay, that is second stage is anaerobic treatment.
Okay.
Oh. And then the third stage is the aerobic system. Okay. So in anaerobic and aerobic, they are all related to biochemical reactions.
Okay.
So why the BOD is so important here? Yeah, but the BOD control is not so easily. Precisely speaking, okay, the third stage aerobic process. The aerobic process, because it's related to the microorganism recycling. You know, recycle the bacteria back to the original reactor, because it's consists 2 reactors.
Okay.
One is aeration tank, another one is sedimentation tank. So after sedimentation, for aerobic process, you need to recycle the bacteria back to the aeration tank to keep the concentration of the bacteria. So, and I think that is very, very difficult for those pig farmers because they have this kind of training. So that's why we need to develop an automatic system. So they don't need to worry how much amount I should recycle and when should I recycle, because we have the sensor that can automatically monitoring those some key parameters, and that will automatically control it, do everything for them.
So you just mentioned it wouldn't be good for the pig farmers to be the ones like handling all the machinery, all that. That's why we need the automatic part. But how much does it really cost, or how do you see it happening not in Taiwan, because Taiwan is usually a country where there is, let's say, money to be invested. How about third world countries where the water quality is very bad? What do you recommend, or
Okay.
for the price? I mean,
Yeah,
as well.
I think, as you say, but I think in Taiwan, all those pig farmers, if they cannot do not need to pay any money, I think they will like it. But
Of
that
course,
is
if it is
that
for
is impossible. So
every farmer,
So we'll
everywhere.
try to reduce the cost. Okay.
Yeah.
So I have developed several system. Okay, there are different version. Okay. So we have a probably more complicated one. We have a simpler one. Okay, the simpler one. Anyway, you need a computer.
What does a
personal-
computer does?
Okay, a personal computer.
A computer.
Okay, because you
sorry.
need the control algorithm
Yeah.
and do the control actions. Okay, so you need a computer, and then you need some sensors. Okay, the sensor that for the SS sensor, suspended solid, and I think the simpler one is one is in the aeration tank.
Yeah.
In aeration tank. And another one is in the effluent, the discharge port. We have one in the sedimentation tank. Okay. So the one in aeration tank, that can tell you how what is the concentration currently in that tank. So that means the bacteria concentration. For example, The normal, okay, like a summer or like a summertime, okay. Probably we want to control the concentration at a 3,000 ppm. I'm talking about suspended solid.
Yeah, ppm means parts per million.
Parts per million or milligram per liter. Okay.
Milligram per liter.
And the one for the discharge port, the sedimentation tank. Okay, so I can set the effluent standard or let the limit. Say, okay, if the governmental regulation is 100 ppm.
Yeah.
Okay, so I set that at the limit. If over that, okay, it will recycle back. It will never discharge out.
Okay.
So that will keep that will not pollute our environment, or they will not get a ticket from the government. That's very important.
Taiwanese government gives tickets if you don't follow these rules for.
Regularly, probably every 3 months, they need to report the water quality to the government, or probably you have somebody, okay, they just tell, okay, that pig farm probably their water quality is not good, so the officer they will come to their pig farm and take the effluent and to analyze. If over the limit, okay, the valid the limitation, they need charge probably 60,000 NT dollars.
60,000 NT dollars
for one ticket.
That would be like $2,000 US, right?
Yeah, around that.
Whoa, it's pretty high
for one day.
Per each time. Okay.
Yeah. Okay. And then they need to improve the system. Okay, say probably they will give you 2 or 3 months, and you need to, okay, and after that, if it's still the same, probably you got trouble, you need to close the farm.
Doctor, and if this, let's say, if the government is giving tickets, means that the government helps the farmers to put all of this machinery? Or
no.
Starting from what size of a farm?
Those pig farmers, they need ask help, probably from the consulting company or some expert.
Okay.
Like me.
Nice.
Okay. Try to improve the system.
Yeah.
Okay, so you need to probably redesign the whole system. Yeah.
Doctor, and right now we are talking about the water quality because they use water to move all of this pig manure, and then they need to discharge it, right?
Yeah.
So is there any possibility to not use water? Use another type of technology?
You're talking about another patent. I have another patent.
Oh, okay. Can you tell us about that, please?
Okay. So because in Taiwan we use too much cleaning water.
Yeah.
Okay. So, and we know most of the pollution is come from the solid manure. So before they clean the pig pens, if you can remove all those solid manure, so they can reduce 90% of the pollution. Because you only take about 10% of the pollution.
So the solids are 90%.
Yeah.
Of it.
So my patent is try to remove that. I have a suction system.
Okay.
Suction system. Okay, and install in the pig farm. So it's just like link a whole pipe, like a factory. So in each pig pen, when the pig farmer go over there, they just pick the tubing.
Yeah.
Okay, and make suction. Yeah.
And then later, all of this manure, where does it go? Where can it go?
Okay.
I know that you've got another.
For those solid manure, okay, most of the pig farmer will send to the composting or make a compost. It can be as a fertilizer.
Yes.
Oh, sure, another using. Like me, I am doing the anaerobic digestion project. I can use that to produce a biogas. That's the energy, clean energy.
I did a little bit of research and I found out that if we have 5 pigs, more or less, and using the manure produced per 1 day, we could only turn on one light bulb, 100 watt light bulb, because of these pigs would generate more or less 20 kilograms of manure.
If-
Then these 20 kilograms of manure would produce 1 cubic meter of biogas.
Okay.
Am I right? Or
No. Your assumption, I think, is not good.
okay.
Okay. Because 5 pigs, that
Yeah.
scale is too small. You don't need to worry about that because the cost of the equipment is too
No,
much.
but talking a little bit more like
If I have 5,000, will be better.
okay, let's talk 5,000 pigs.
Okay.
Then we could light
1,000 times of that. Yeah.
1,100 watt light bulbs.
Uh,
So
one easy way, 5,000 in the class.
yeah.
Divide 1,000, so have a
For the people who don't know, Dr. Chou is my professor for waste treatment engineering. That's why he's scolding me for not putting attention in class. No, I put attention, doctor.
I think we have some way. Okay, 5,000. Oh, there are several assumptions. Suppose if each pig can produce, say, 0.2. For one pig, 60 kilo. Say 10%, 6 kilogram or 6 kilo. Oh, so sorry, I just.
No worries.
I just forgot that number.
It can be an approximation. Yeah, don't worry.
5,000.
I mean, this is what I found in internet, that with 5 pigs you would have enough biogas to turn on 100 watt light bulb for 10 hours.
For
That's what
1
I
hour?
found. Well, that's what I found.
Let me check. Yeah. Oh, because in the class, I told you how to choose the right equipment, how to buy.
There are many
the power generator.
equipments.
The power generator. Okay, so yeah, but you are talking about
The smallest
thing.
power generators, how do they work, or how much energy can they produce?
Okay. I still remember probably 1,010, 140, 10 divided by 10, 5 divided by 10, 500 divided by 7, 100, 5,000, 10,000, 168.
The maths are going on here in the
170,
podcast.
Sorry. I
No
still
problem.
just think that. Anyway. Okay, I try to remember that.
It can be
number.
only an approximation,
The
as I said.
city, say, okay, say, so we probably have a 500 cubic meter biogas will be produced per day. That's
Yeah.
daily production. Okay.
For a 5,000 pig farm.
5,000
pigs
Okay.
farm.
Sorry, it take so long time.
No worries, no worries.
Okay, so and
Well, everybody saw your mathematical.
500 cubic meter
Ability.
Okay, if we use the new machine, okay, divide by 0.5, so we can have a 1,000 kilowatt hour.
Yeah.
1,000 kilowatt hour. They can produce such electricity. 1,000 kilowatt hour.
It would
The
be
electricity you can use.
1,000 light bulbs. Yeah.
1,000.
1,000. Yeah, right?
Kilowatt.
If it's 1,000 kilowatts, then
That means if 1,000, if you have one bulb that is 1 kilowatt, but you never use so high. Probably you use
let's say 100.
100.
100.
So
Yeah.
100. So then you can have 10,000.
Yeah. Also, 1,000.
I think one.
Okay, let's say
1,000.
1,000 bulbs, each bulb of 100
Okay.
watts. You can have them turned on
Or 10 hours.
for 10 hours.
For 10 hours.
Yeah.
Yeah, that's right.
Do you think that all of this quantity of peaks in order to turn on this amount of light bulbs, do you think is it a good amount of energy produced?
I think it depends.
It depends.
Okay. If you use those biogas to produce electricity, because the heat efficiency probably only 20 to 30%,
Yeah.
that is quite low because it lost around 70 to 80% of the heat, the energy. So another way is you can use those direct heating, like for cooking, or use for the bath, for the bathroom, or take a shower. You have the heat water for household use.
Okay.
Yeah, that I think that is can extend your usage for those energy.
Okay, and for this type of machinery, it can be put inside of a house, let's say. Or
I think it's
what
too big.
machinery would be
It's
needed?
too big. For electricity, I think the power generator, because it's quite huge, so it's not for.
So it must be like
not
a
for the
company.
houses. Like a pig farm is okay.
Yeah.
No, but not for house. For house, probably you can use those biogas. You can use those biogas, but that's just for cooking or heating water. No. In pig farm, they were heating to keep the warmth of the piglet.
Yeah. Oh, yeah, that's right. That's something else. For pigs, you need to keep them warm,
Yeah.
right? And more here in Taiwan, that sometimes the temperature is very high, sometimes it's very low.
Yeah, like these few days.
Yeah, like these few days. And doctor, can you tell us about something more about your work in this field of water treatment?
Okay. For the automatic control of the wastewater, I say I have some patent.
Yeah.
And we already make some movies.
Movies.
Yeah, a long time ago. Yeah, in television they broadcasting that.
Great. Can you tell us about it?
Yeah, because
Like, what was the content of
because
that movie?
it's
or-
belong to a government project.
Yeah.
So I have developed that system and try to extend use that system. Yeah. So in the TV, they broadcasting that. So and I show them how it works. So the pig farmer, even they don't have that ground, you don't need to worry about that because all the system is automatic control. Even is all of electricity. When the electricity come back, okay, the system they can continue work.
Do these systems take
save energy
Yeah.
and also can precisely control that system, and can save the money. They save them because they don't need to pay the ticket.
So these systems, do they consume a lot of energy? Because maybe
No.
they are.
The control system is
Yeah.
not. The wastewater treatment system they already have. So I just add the control system
Oh,
and the
okay.
sensor. You know the computer, they will not take a lot of the electricity.
Yeah.
Yeah.
Okay, doctor. To start the ending of this podcast, I saw that you studied your master's degree in Hawaii.
Uh-huh.
How was it?
How was it?
Yeah, it sounds very
It's a nice
interesting.
place,
Yeah.
It's a good place for vacation. You know, my
So
my PhD in Florida.
Yeah, I saw both
very-
of them.
Yeah.
Can you tell me why did you choose those two
Why I
places?
choose that?
or-
Okay.
What was your parents' reaction or
Because scholarship.
scholarships?
Yeah, they give money. I don't need pay anything.
Yeah.
So when I go to sign the visa to the AIT,
Yeah.
okay, they say, oh, Hawaii, and you don't need to pay any money. They will give you money. Okay, it's a good deal.
Yeah. Did you learn surfing or something like that? How was your experience? I think that our audience would like to listen a little bit
Oh,
more of those stories.
no. I have I've been there for 3 years.
Okay.
Years. So just study and do the experiment. Sure, I probably on holiday. Okay, some the weekend, some special weekend. Okay, I will take vacation and take a plane and fly to the small island.
Yeah.
Yeah, vacation. Yeah, just cost me $99.
That's
for one
great.
weekend.
That's great.
Yeah.
And been living there for 3 years. Did you came back to Taiwan in that?
No. After that, and I moved to Florida.
Oh,
for
straight.
for PhD degree.
Yeah, yeah.
In Hawaii, only master degree.
And how long did you spend in Florida? How long time?
4 years.
4 years.
Yeah.
And then come back to Taiwan?
Yeah. Yeah, because I like to be a professor in National Taiwan University.
That was your dream since the beginning.
You can say that.
Nice,
Yeah,
nice.
to be a professor in this university.
And how much more time do we have to go to your classes? Are you planning to keep on imparting classes in the future? And which courses?
You mean except the wastewater?
Yeah,
the
like
waste
some
treatment
other
engineering?
courses that you are planning to give to students for or audience to listen.
Okay,
to go?
like next semester, I will deliver a course related to anaerobic digestion.
Anaerobic digestion.
It's just doing experiment, no exam.
No exam, people.
Yeah.
So
Just practice. Yeah.
just
So
practice.
so that course is anaerobic process and practice.
I hope to see you next semester then, Professor. And
You better not flunk out.
excuse me?
Oh, I mean, if we can pass the grade, sure, no problem.
Yeah, it will be for sure.
Oh,
Yes?
I will tell you later.
Okay, no worries. So we've got some things to talk about later. And this is where this podcast ends. Thank you very much, Dr. Chou, and see you next time.
Yeah. Okay.
Thank
None of us shake hands now.
Okay, again.
Okay, Elva.
Perfectly. Thank you very much for watching this episode. Like the video in case you liked it, and leave a comment below for further improvement of our content. As well, if you like topics such as new technologies, research done in universities, or even wonderful stories of incredible people, subscribe to our channel. This is how you find us in social media. I want to give a special thanks to all my sponsors and team members. Y recuerda, toma pulque y come nopal, que la próxima semana otro video se va a lanzar.